Do you struggle to make good scientific figures? Yeah, me too. But over time, I've improved my workflow, and now I feel I've got a solid handle on how to create figures that are not just clean, but actually informative. So in this video, I wanted to share with you my step-by-step process or my checklist of the things I pay attention to when I create my figures. I use Python for plotting and Inkscape to put everything together into one final figure. So you'll find the code and some examples in the description below. So let's get into it. Here I already wrote the importation of some libraries that are needed for plotting in Python. Then here I just created some fake data sets. So I created the y1, y2 and x. Let's go ahead and run this. And then if we want to make just a simple plot as an example, we can just plot the y against the x in different subplots like here. And this will give us some graph like this. So this is of course a very simple graph, so we will need to improve it. The first thing that you might be thinking about doing is of course setting some labels. So for example, we could go ahead and set the y label of the first graph to something like the score, because it's important to know what we are measuring there. And on the second subplot, we could do the same thing and say that, for example, this y2 is a measure of the error. So this already makes the graph way more explicit. Then one thing that I always like to add is the marker points like this. So that is explicit where we actually took the measurements. So now we know that, for example, we took measures at the x equal to 40 and not at 42. And this is important because we could have been sampled all this line densely or not. So it's kind of important to know which kind of data we are dealing with. So this graph is already pretty better than before. So let's try to go ahead and save it. So for this, we just use this save fig, and then you add the path of the file where you want it to be saved. So I just add it here in my folder and name it example1. So we can go ahead and see it. So here is the saved PNG file of this graph. So we already can see that it didn't really save the graph very well, because we could before see the y label of the error, and now it's completely cutted. So these are things that we have to take into account, because it's the way that Python exports the image, so we have to tweak a lot of the parameters, and we'll do this after. Another thing that we would like to show you is that imagine that now we want to add this in a figure, and this will be your subfigure A, for example. In Inkscape now we can go ahead here and go import, and you could import this figure like this. And you can see that this figure is quite gigantic. So here we have like A4 page. That is our canvas, and this is where we are drawing our figure. And our figure here is quite gigantic. So of course we could go and resize it, but then we will, for example, if we would resize it, the letter type will be very, very small. So when you export this and put it in your paper, then you'll not be able to see the labels. So this is our things that, again, we need to take into account when making these figures. So for me, I found a nice workflow to make the figures the best way possible. So this is what I'm going to show you now. I would like to show you this checklist for things that I pay attention when plotting my graphs. That works very well for me, and hopefully it will work very well for you too. So the first thing I always pay attention is the figure size. So I set my figure size before anything else, so that then I don't have the problem that I was just showing you before. I also make sure to label all my axes, so that indeed I know which quantity I'm representing in both axes. Then I also adjust the thickness of the axes. So for example, here I have measurements at 50, but the next measurements are at 100, and maybe I don't need even to plot the 60 and 80, so this is a bit a personal taste, but it could be important or not depending on your type of graph. So I also adjust where my thicks are. Then I also adjust the label of the thicks of the axis. So for example, here I have all these labels, but maybe I can just plot 2 of these labels. And even the label itself, it has a lot of zeros behind. So maybe I can adjust this to write it in scientific notation so that it doesn't occupy so much space and is so strange to see it like this. Then of course I also add a legend and sometimes a grid. A legend is important because, for example, here we have these 3 lines with different colors, but we don't know at all what each of them represent. So it's very important to legend each of the lines that you are plotting. Then I also take care about the font size. This is indeed because when we then export this figure and we want to put it in a manuscript, we want to make sure that we can actually read all the labels and they're not too small or too big. Then a bit extra, I also try to adjust the spacing between the labels and the thicks and the thick labels. So maybe, for example, here we see that maybe there's too much space and we want to make it tighter because our image is already too big and we want we don't have too much space for these white spaces, so we can reduce it, or even the white space between the axis and the image that actually then is saved. So we can adjust all these spacings, and then we can also adjust the font type to whatever you prefer. And then I export it in a way that has a good quality and also that I can read in Inkscape, and then I can adjust it the best way that is needed in Inkscape. Okay, so about the first point, usually I very much like this figure that explains the different image sizes that we can have in a manuscript. So of course we can have an image that occupies all the width of the page, and that will be maximum 119 millimeters in width. You can also have an image that is small and it just occupies one of the columns, and this will be around 90 millimeters. And then of course you can have images that occupy different spacings between one column and the 2 columns. I think this is just important to have in mind because it's not worth it to make a figure that is 220 millimeters width, because it's not going to fit the page, and then you have to resize it anyways, and all the work that you had before to resize it, it just goes to waste. So let's do this first. So the way to do this is to define the figure and the axis first. So this is like this, plt.subplots, and then we want 2 lines and 1 column. And then we can define the figure size. Well, like a figure size of 80 millimeters so that it fits in a column. So here the figure size is defined in inches. So I will write like this, 8 centimeters, and I will divide it by 2.54, which is a conversion from centimeters to inches. And then in height, I will want it to be 7 centimeters, so I'll divide it as well again for this conversion factor. And then I will add a DPI of 300 so that it has a good resolution. So now to make the plots is a bit different than before. So before we're doing plt.plot and doing our plots after we call the subplot. Here is a bit different, so we already defined our axis here. So now we just need to call our axis. So we'll call the first one axis 0, and we'll do plot, and we do x, y1, and then we can already put this marker like we had before. And then for the second subplot, we'll do something similar, plot x, y2, and put the marker again. And we have these subplots. So we can go ahead and do something similar by labeling the axis like we did before. So here that is done by calling set y label, and we can label the first y-axis as the score like we did before, and for the second subplot label we call it error before. Okay, so now we can go ahead and save it as well. So I'll just copy this line. Now we'll call it example 2. And we can go ahead and open it. So it's interesting again that we see that the figure that is saved is not exactly what we have seen here, and that is because the resolution that we are saving the figure is different from the resolution that the screen is displaying. So what we can do to avoid this, so that we always see the same thing as we are saving, is to call this line. So it goes like this: config inline backend dot print figure max and we call bb box inches and none. So now we are seeing exactly what it was saved before, like this. So I like to do this because like this I can tweak my figure the way I want it here in Python, and then I'm sure that when I will save it is exactly what I'm seeing. So they are consistent. Okay, so this is done. Now we can go ahead and adjust this figure, so we can see that this part is cutted. So let's try to adjust the subplots so that we can see everything. So to do this, we can write subplot adjust, and this will allow us to adjust the margins of the left, right, top and bottom of the figure. So we can go ahead and say that, for example, left is this, then this needs to be, tweaked according to your data, and you just have to play around with it to make sure that you can see everything you want. And the top equal, so I'm giving it parameters now, and then we can tweak it if it's needed. Something was not right because it's subplots adjust. Exactly. So here we can see that there are still some things a bit off, but I will leave it like this for now because we'll still adapt the size of the labels and everything. So later on we will adjust these parameters better. So we already set the figure, the size of our figure. Let's proceed to the second one. Let's make sure that we label all our axes. So we already have the labels on the y-axis. Let's do it also for the x-axis. So here I don't think it's useful to label the x-axis of the first subplot because it's actually exactly the same as this one. So let's just label the second subplot. So we go and do x-axis 1 and we do set x label now, and we can call it month, for example. Okay, so now we have it. The next thing is to adjust the thicks of the axis. So for example, here we have a lot of measurements at the earliest months, but not so much at the latest months. So actually 60 and 80 is pointing to no measurement at all. And I find it more useful to have labeled the ticks on the places where we actually have the measurements. So for example, here. But this is of course personally, and it depends on the type of data that you are trying to show and what makes sense for your particular plot. But in this case, I would like to have the ticks exactly where I have my measurements. So to do this, I'll just set the ticks on each of the subplots. So I'll do this, set x ticks, and I will set them on our x values. So then it will be on the measurements. And the same for the second plot. So now we have it 10, 20, 30, 40, 50, and then there is a gap, and then we have the last measurement at 100. Okay, next thing is to adjust the labels of the ticks. So for example here, I think it's unuseful and it makes it more crowded to have these labels here because they're exactly the same as the plot below. So I would like to keep ticks so that I know exactly that they correspond to the same as the bottom graph, but I will remove these labels. So to do this, we use another function. I don't know if it's called function, that is called set x tick labels, and we'll put it to empty, the first one, as we can see, and then for the last subplot, we can actually, if these are months, we can also replace these numbers by actually strings. So we can call it January, February, March, April, May, and then actually the last one is not following, so let's say it's October, and that's it. So another thing that happens often is that the labels get too crowded and then we cannot actually distinguish them. So for this we always have this feature of calling the rotation of the labels, and then like this we can already distinguish them very well. So we took care of the labels on the x-axis. On the y-axis we have here these labels, and as I mentioned before, the numbers like that are not very informative, so I would prefer to have this in scientific notation. So for the second plot, which has y numbers that are very, very small, we can do something like formatting the labels to be in scientific units. So we can do like this, tick label format, and then we say which axis, which in this case is the y, and we call the style, and we call it scientific, and we can do the limits like 0, 0. So as you can see now we have this label in scientific format. So this is 0 to e to the -3, -1 e to the -3, and it's just better than having 0.000. It's not very informative, and like this is way cleaner. For example, here we actually already have the labels with 2 decimal points. But if we didn't, we could try to tweak this as well. So one thing that we can use for this purpose is something called format string formatter. So I'll just import this and then I will explain it better. So I'll need to do this, matplotlib sticker import font string. Okay, so here I could go ahead and on the first subplot I could say that the y-axis I will set the major ticks of the y-axis, major formatter is this format string formatter, and then we call it like this percentage, then 0.2f, which is 2 decimal points, and then we just close it. So I put here this comma unnecessarily. Okay, so here I have 2 decimal points, but I could, for example, have 3 decimal points. So then depends on your type of data. We could also adjust this to have decimal points that you want. So I think this line here is very useful to adjust the access to the decimal points that you want. So next, I would like to adjust the legend and the grid. So actually we know which kind of lines this refer to. So we just need to add the legend in one plot if they are part of the same graph. We just need to add it in one of the subplots to avoid repetition and to avoid crowding a lot the graphs. So we can do something like this, legend, and then our legend. So for example, if we have 3 lines, we can call it option A, option B, option C. And we can also place it whatever it fits better on the graph. So here I will put it on the upper right corner because there's some free space. Upper between strings, upper right. Okay, voila. So here we have. And I will also adjust, add then the grid. So we can add just like this, grid, and for the first axis as well, the first subplot, I mean, grid. And like this, I think it makes it a bit more scientific to see exactly the grid below the graph. So let's first tweak the sizes of the labels. So since now we have to do this for both subplots, I will just make a loop to make it easier. So I'll do for A in X, and I will set the labels. So A dot set Y label A dot get Y label, this, and then I will add the font size equals to 8. So like this, it does it for all the axes, and I don't need to do it manually for each one of them. So as you can see, the Y label is reduced now and is way smaller than before. So we can do the same for the X label. So I'll just copy this and replace everything for Y label. So now the Y label is also, well, we cannot see it because it went down, but is also the font size of 8. Now we can also adapt this size of the ticks because now they are too big. So for this we do a dot tick parameters, tick params, and we will say that the axis that we want to refer to is both, so both the y and the x-axis will be affected by this line, and we'll do label size equal to 7. So I like to make it a bit lower than the y-axis. This also taking into account that when we then write the manuscript, the font size around 11, 12, so a font size of 8, 7 for the figure is appropriate. So now all the ticks sizes decreased already, so now we can again see the X label. So we might notice as well that then now we have this 1e to the minus 3 that did not change label size. For this we need to tweak it individually, so we need to do this. We need to go here on the axis that we did that, on the second subplot, and we have to write y-axis dot offset text set font size and then we put it as 7 as the other ones. So now it already changed. So now all the labels of the axes are with the appropriate font size. We still have the labels of the legend that are quite gigantic, so let's adapt this. So we go here where we define our legend, and we will set it to font size of 7 as well. Et voila, it's already quite smaller. Okay, so now the next thing is we can adjust all the spacings. So for example, here the legend is still quite big, the markers occupy a lot of space, and there's a lot of spacing between them. So if we need, we can adjust all of this. So the way to do this, especially for the legend, is to add other parameters here. So where we have the legend, we'll add other parameters. So one of them is the marker scale, go to 0.8. So this already we can adjust the scale. So for the markers, so if we put 1, we see that it's quite gigantic. So we can put it like to 0.5. It's already way smaller. Then we also can adjust the length of the handle. So it's handle length equal to 1. So is handle length. Okay. So like this, this line is quite smaller already because we don't need it too big. It just causes distraction. Another thing that we can adapt is the space between the marker and the text. So this is handle text pad. We can, for example, if we put it to 1, there is a lot of space between the marker and the text, so we can set it to a lower value, and they are already quite close. Another thing that we can do is the spacing between the labels vertically. So for example, if we put 1, they have a lot of space between them, but again is not needed, so we can put this a smaller value so they are more closer together. And then finally we can also adapt the space to the borders. So for example, if we have like this, the space between our legend and the border is quite large and it's unnecessary, so sometimes it's useful to reduce this value to a smaller one so that it can fit better your graph. And like this, for example, here we can see all our markers like clearly, and the legend is not disturbing anything. We can adjust this, for example, between the ticks and the labels. So, for example, we can adjust this here, where we are saying that we set the label size of the ticks. We can say have also a parameter that is called a pad, so it's exactly this distance. So if, for example, we had a pad of let's say 3, there is quite some gap between the legend and the tick. I mean the legend of each tick, and if we put it to smaller value, we are quite closer together, and this saves quite some time. Then another thing that we can adjust is as well the space between this label and the tick labels. So for this we can go here where we set the X label to months, and we can also add pad. Well, here is labeled pad, and we can have a value of 2, which makes it go a bit closer to the ticks, or even 1, and is way closer. I don't particularly like to see the Y labels not aligned, so I usually set them exactly to the same distance. So this I do with here, I do axis y axis dot set y label chords. So this is a manual setting that is not ideal, but like this. So it is not ideal to do this manual tweaking, but like at least like this they are both aligned. Okay, then the final thing, one of the final things is the font type. So right now it is the default one, but you might want to adjust it to your preferred font type. So to do this, we do this before we plot the figure. So we do plt rc params font dot family, and we can call it, for example, the serif one, and we then this is to call the font family, and then we set exactly the font that we want inside the serif ones, which is, for example, the Times New Roman. So this will set the font type Times New Roman, but then particularly I prefer the sans serif ones. So here I will write like this, sans serif, and I will call another one that I think it makes I like more. Here I forgot an S, and this is one that I personally prefer more. Figure looks way much professional, so we have all the labels correctly applied. We know what which line represents. We have the numbers in scientific notation, and it's just way more suited for a publication than the first one. So let's just go ahead and save it. We'll just save it as example 3, and we'll add a DPI of 300 to have a good resolution, so we can go ahead and see it. I see that there is some space between the bottom and the label month, so we can adapt this. So as I said at the start, we adapt this with the subplots adjust, so we can just, for example, put less spacing for the bottom. We can see it again. Now it's more tight, and we don't have so much white space. Okay, now I like to save this actually in SVG format, vector format. Okay, and now we can go to Inkscape, we can delete our previous figure, and we can load our new SVG figure. Not open import. Here is the SVG figure. You can either load it as a current image, or we can use as you can import it with a link. So this means that if you change your figure on the folder, the figure here will update accordingly. And I do prefer this option because if we redo the figure and we adjust some axes, we adjust wherever it is, the figure will update here. And I will increase the DPI to 300 like we saved it, and here is our figure. So our figure now has exactly the size that I asked for, so 80 by 70 millimeters, so like one column, and it's well prepared. So then my recommendation is to adjust the page of Inkscape to the size that you want. So before we say that we want to just to have a one column image. So we go here, document properties, and we'll set the width to just, for example, 85, it's more than enough, and the height of 100. So that's it. Then we can, for example, use this tool that is also in sans serif to add extra labels. So you can say that, for example, this is the subfigure A, and you can put this now in 11 size. So as you see, this is in 11 points, and this score is in 8, like we said it before, and everything makes sense. You don't need to resize the image, you don't need to resize anything else, everything is ready to go. So you can say that this is a subfigure A, that is before your applied method, for example, and you can put it here, and then you could even create another one, a second subfigure. You can adjust the position of the label. So this is, for example, at position 240. We'll do the same here. We'll call it subfigure B after method, and then we can go here, for example, and create another figure and call it SVG example 4. It really doesn't matter now. I'll just run the same code just to have a different figure. I will just adjust the size of my document to 100, and now I'll do again importing this second figure, again with the link and the DPI of 300 like we did before. I'll just put it here exactly on the same position as I have the other one, and voila. Now indeed we don't need so much spacing, so again I will just adjust the spacing left. This will be a bit by, of course, trial and error. Like this, I think it's enough. Even I will like them both to be a bit more centered. And like this, you have like a nice figure that is composed of several subfigures. And in any point, if you need to rerun the codes, everything will be updated here automatically. Then to export this figure, you just go here on the file export, which is this. We'll export this document, which is this page here that we are seeing. We can choose the DPI again. You can choose if you want the PNG and which type of format you want. So for example, for some journals, they require some specific format. So for now, let's just export it in PNG, and let's just save it on the same. So final figure. And here you have your final figure that then you can input in your manuscript. So around these figures, everything is black, but this is because we have a transparent background. You can also adjust it if you prefer, but usually that's not a problem because the background is always white in the documents, so this will not be a problem.